Water, the very essence of life. Without it, life as we know it would cease to exist. We tend to take the readily available clean drinking water for granted here in the United States, but that's not the case everywhere on this planet. Modern technology helps us to produce clean drinking water through pumps and filtration. But what do you do in a remote location, or in the event of a natural disaster where electricity or fuel is not available to run a conventional high-pressure or high-volume pump? Sure, you could use a typical hand-operated lever pump, but how long can you sustain the energy needed to produce enough filtered water for you and your family, let alone an entire community? The answer? The gravity-assisted Feltenberger pendulum pump, a simple-to-use, hand-operated device that can pump and filter 1,000 gallons of pure drinking water per hour, with no electricity, no fuel, and very little fatigue to the operator.
I'm Bruce Feltenberger, and I'm here to share with you the results of some efforts that have been in the making for over 40 years. Back in the 60s, I had an idea of how we might be able to build a machine that would enable us to use gravity to help do work. And today, we have brought this into fruition with what we call the Feltenberger pendulum pump. It's a very easy to operate pump. It's operated manually. It's designed to go into areas where there's no electricity or fuel available. And in this case, we're sending it down to Haiti to help make clean drinking water. It's hand operated and it pumps a lot of very clean water. Very happy to share that with
you. I'm Art Drentlau. I'm one of the founders of the company, and I'm going to get to accompany this machine down to Haiti and make clean drinking water for the people. It's very simple to operate. It uses a couple of mechanical advantages that are subjected to gravitational acceleration. You'll see that it works in this fashion, a lot like pushing a child on a swing. And I can push this arc as high as I want it to go. And if I want to go 360 degrees, I can do that as well. And it's continuing to pump while I do that. I can go faster if I like. And it'll pump in both directions.
What's unique about the Feltenberger pendulum is that it reciprocates in two directions at the same time. We call that a double reciprocating pendulum. Now, I'm going to demonstrate that for you. What we mean by that is as the pendulum swings back and forth like it's doing now, it also slides in a linear direction by the axle moving in and out. Perhaps you can see that right there as it comes in and out while I'm pushing it this way. And the benefit that we have from doing that is that it produces a linear straight line motion that we connect to a reciprocating pump for pumping water. In between the pump and the pendulum is a device that we have a patent pending on that enables us to transform the energy from rotary to linear, and we develop a mechanical advantage at the same time while we do it. So it makes it very efficient then to push the pendulum in this manner and produce output work at the pump level.
Hello, my name is Matthew Buttrick. In this area of the machine, we have a device which converts the rotary motion of the pendulum into a reciprocating motion, which drives a piston pump, which allows us to filter 1,000 gallons of dirty water and produce clean drinking water an hour from a stream that you would find near a road or in the back of a farmer's field.
Now we'd like to show you the prototype machine. We use the prototype machine to develop the technology for the pump that we're taking to Haiti. We're going to operate it in two different modes. We're going to operate it in pendulum mode, and then we're going to disconnect it, and we're going to operate it strictly as a lever arm pump. What you're going to be able to see of what we developed after a lot of different tests is that the fatigue factor in operating it in this manner or a rotary manner is very easy to operate. And then when we disconnect it, you'll see that it's very hard to operate strictly as a lever arm pump. And now you can see that we've disconnected the piston drive arm from the pendulum pump, and we have the pump set up strictly as a lever arm pump. It's interesting to note that the lever arm is 16 inches long, which is the same setting that we had on the pendulum pump. It's also interesting to note that when I pull the lever arm back and forth, we're going 1 inch. And you will also note that when we're going 360 degrees or back and forth in a horizontal position with the pendulum pump, we're going the same distance. Now here we go. We're going to show you just how hard it is to pump with strictly a lever arm pump. You can see that it's not easy. Even if I want to use 2 hands, I don't want to do this very long. So give me gravity-assisted power any day of the week. Oh, that's it for me.
I'm standing now on the work platform of our largest pendulum machine. This pendulum weighs about 18,000 pounds and measures 18 feet in length from the center of the axle down to the tip of the pendulum. With this machine, we hope to demonstrate that gravity-assisted power can produce commercial-grade electricity at about twice the efficiency that's currently found in most power plants.
Gravitational Energy Corporation, for the betterment of mankind. For more information, visit our website at gravityassistedpower.com.